Hello friends, in this video we are going to study about the pressure measurement device manometer. Here we will study its construction, its principle of working, its advantages, disadvantages along with its applications. So let us start with our topic. Manometer, it is a very simple and common device which is used for the measurement of pressure. Now this manometer, it is sometimes also known as the wet meter. It is called wet meter because the fluid whose pressure we want to measure, that fluid is bring in contact with another fluid. So we can say that fluid whose pressure we want to measure, it is wet with another fluid, and this fluid is generally the mercury. So the fluid whose pressure we want to measure, that is bring in contact with another fluid, generally mercury is used, and this mercury is going to be displaced, and this displacement of this fluid, that is mercury, due to the pressure on the existing fluid or pressure of that fluid, that is a measure of the pressure in the fluid. Okay, so due to the pressure of this fluid, this another fluid is going to get displaced, and this displacement is an indication of the pressure. The more the pressure is, the more the mercury will be displaced in the tube. Now, why mercury is mostly used in the manometers for the pressure measurement? Because mercury is having a very high density. So if we are using a very small amount of mercury, that can also give us the results. So that is going to minimize the size of the device. Okay, so mercury is having very high density. If instead of mercury we are using water, so water is having less density as compared to mercury. So the amount of liquid required for the displacement or for the measurement of pressure, that will be more in the case of water and less in the case of mercury. So to reduce the size of the fluid required, mercury, which is having very high density, that is used. There are various types of manometers depending upon the shape of the device. And these types of manometers are tube manometer, well type manometer, incline type manometer, ring type manometer. So depending upon the method which is used for the measurement of pressure, depending upon the inclination or shape of the tube, there are different types of manometers. So first is U-tube manometer, then we are having well type manometer, inclined type manometer, and ring type manometers. There are several other types of manometers also available. Now here in this video we are going to study about the most common type of manometer, which is the U-tube manometer. This U-tube manometer, it is very simple and it is easily constructed. Let's see its main parts, that what are its main components. It is called U-tube manometer because of its shape. Its shape is a U-shaped tube is there. Okay. So because of its shape, it has derived its name U-tube manometer. Now this U-tube manometer, it consists of a U-shaped tube, and in that tube the manometric fluid, that is mercury, that is filled. Now on this mercury, the fluid whose pressure we want to measure, that is put. Okay, so due to the pressure of the fluid, the mercury which is already filled in the tube, that is going to displaced. Now this manometer, because it is having the U-shaped tube, it is made up of glass. Parallax glass is used for its construction so that the observer can easily see the movement or the displacement of the mercury. Now on this glass, the graduations are made. Graduations means that scale divisions are made so that the displacement of the mercury, that can be easily seen on the graduations of the scale. So suppose that this is the U-tube. In that the mercury is being filled. So on one side of the tube there are scale divisions. So when pressure is applied here, or when the fluid whose pressure we want to measure, it is filled on one side, so due to that pressure this mercury is going to raise its level. Okay, so this raise in level of the mercury can be studied with the help of this scale. So this glass tube is having graduations on it, and these graduations are in terms of mm, that is millimeters. So the rise in the level of the mercury can be easily studied. So that was the construction of the U-tube manometer. Let's study its working. So this glass tube is having graduations over it, and these graduations, they can be, means it is having divisions, so we can directly read the difference in height occurred due to the pressure applied. Now these graduations can be in terms of millimeters or in terms of pascals. Pascal is the unit of pressure and mm is the unit of height. Okay, so height can also be measured and the pressure difference can also be measured. So accordingly we can calibrate our scale to get the readings for the pressure or the height. So this was the construction of the U-tube manometer. Now let's see that how this manometer can be used to measure the differential pressure. Now, as I have said that in this U-tube manometer, a manometric fluid is filled, and this fluid is generally the mercury. So, Suppose that this U-tube is filled with the mercury fluid and no pressure is being applied on both the sides, left side and right side. Means that this is open to the atmospheric pressure. So same pressure is being applied on the left and the right side. So the level of the liquid in both the tubes, that is in the right limb and the left limb, that will be equal. Now suppose that here pressure P1 is applied and here pressure P2 is applied. Okay. Suppose that here this no pressure is being applied and only P1 is applied. So fluid is going to displaced in this direction. Okay. Now suppose here P2 pressure is being applied. So if P1 and P2 are equal, the level of the liquid will be equal. If P1 is greater than P2, then liquid will be displaced in this direction, means on the right hand side the level of the liquid will increase and on the left hand side level of the liquid will be decrease. And if P2 is greater than P1, so in the left hand side the liquid will be displaced, its level will increase, and in the right hand side it will be decreased. So according to the pressure which is greater, the liquid will be displaced in the opposite direction. Okay. Now here we suppose that P1 is greater than P2, that is this condition. So liquid will be displaced in the right hand side. Its level will be increased. So earlier the level is this and now level has been changed. So suppose this height is H, this height is H1. We are going to measure the height from the bottom of this tube, which is called the datum or the reference line. Okay. So H1 is this height of the mercury liquid in the left side and H is the height of the liquid, means whose pressure we want to measure. So we are going to mark this liquid with the red color. So this is the liquid whose pressure we want to measure. As soon as we have applied this liquid which is having some pressure, the fluid is displaced in this direction. So this total height is coming out to be H2. Okay. So let's write all these variables value, that what they define. We have supposed that P1 pressure is greater than P2. So this pressure in this left limb, this is left limb and this is right limb. So pressure in this left limb is due to this P1 plus this liquid whose pressure we want to measure and plus this mercury liquid. Okay. So suppose that this measuring liquid, it is having the density rho. Left limb pressure is equal to pressure P1, pressure due to measuring fluid. Measuring fluid means the fluid whose pressure we want to measure plus the pressure due to mercury. Whereas the pressure in the right limb is only due to pressure P2. This P2 pressure plus this pressure due to the mercury. So under equilibrium conditions, both these pressures should be equal. Okay. So let us write the equation for that. So in right limb we are having the pressure P1 plus rho 1 GH plus rho GH1, where G is the acceleration due to gravity, H is the height of the measuring fluid. You can see in the diagram that H is the height of the measuring fluid whose pressure we want to measure, and rho 1 is the density of that fluid. Okay, so rho 1 GH, that will be the pressure, plus rho is the density of mercury, and H1 is again the height of the mercury in the left limb. So that is the total pressure in the left limb. Now that will be equal to the pressure in the right limb, that is P2 pressure plus rho, that is density of mercury, G, and height is H2. So you can see in the diagram that P1 pressure plus rho 1 GH plus rho GH1 is equals to P2 plus rho GH2. Okay, we have equated both the pressures in the right and the left limb. Now suppose that the fluid whose pressure we want to measure is air. Okay, so this term rho 1 GH, where rho 1 was the density of the measuring fluid, and we have supposed that this measuring fluid is air. So this whole term is negligible. When the measuring fluid is air, then this term can be neglected. So the remaining equation will be P1 plus rho GH1 equals to P2 plus rho GH2. So from this equation, if we find out we bring the pressure terms on one side and the density and acceleration due to gravity terms on the other side, we will get P1 minus P2 equals to rho GH2 minus rho GH1. Or we can say P1 minus P2 is equals to rho GH, where H is the difference in the height H2 minus H1. So from this equation you can see that the difference in the pressure in the two limbs of the manometer is proportional to the difference in the height of the liquids in the two columns. So if we want to find out the pressure difference or the differential pressure, that is P1 minus P2, we can find out by just getting the difference in the height of the liquids in the two columns, that is H1 minus H2 minus H1. H2 is the height in the right limb and H1 is the height of the mercury in the left limb. So just we are getting the difference of this. So that is the YouTube manometer, in which the differential pressure is measured by measuring the difference in the height of the columns. Okay. So this was the working of the YouTube manometer. Now comes to its advantages and disadvantages. The advantage of YouTube manometer is that it is very simple in construction. Its cost is very low. Also, it is very accurate and sensitive. And it can be used to measure other process variables. Other process variables like flow level can also be measured with the help of this. If we use the YouTube manometer with the orifice plates, venturi tube and flow nozzles, so with the help of them, we can measure the flow rate of the liquid also. So other process variables like flow level can also be measured with the help of the YouTube manometer. Now comes its disadvantages. The disadvantage of YouTube manometer is that the tube is made up of glass, so it is very fragile in construction. Care has to be taken while handling this because the glass can break and the mercury can come out of it. So it is fragile in construction. Also, it is very sensitive to the temperature changes, because if temperature is going to change, then density of the fluid is also going to change, and density changes are going to make variations in the reading. So it is very sensitive to temperature changes. And also, because we are measuring the height of the liquids in the two columns, so parallax error can also occur while the observer is taking the readings by reading the scales or the graduations on the tube. So it may happen that the observer can take wrong readings of the height. So error can happen while measuring the height. So these are the advantages and disadvantages of the YouTube manometer. Now, as I've said that in the manometer, we are using the manometric fluid, and generally mercury is used because mercury is having very high density. So if mercury is used as the as the fluid, manometric fluid, so very small amount of liquid will be required. If in that case, if we are using water, then water is having less density than mercury, so a large amount of water will be needed to get the displacement or the difference in the height. Okay, so let's see that what are the characteristics which are required for the liquid which is used in the YouTube manometer. The first character is that its viscosity should be low. Low viscosity means that the fluid is not going to flow very easily. Okay, a high viscous fluid is very difficult to move, so viscosity should be low, so when pressure is applied, it can be easily displaced in the U-tube. Low surface tension is required. That is also the requirement for the easy displacement. Okay, so if the liquid is having very high surface tension and pressure is being applied, it will not be easily displaced. Okay, so low surface tension should be there. The liquid should not stick to the walls. Okay, if when the liquid is being displaced in this U tube, then if the liquid is going to stick to the walls, then the density or the amount of the liquid will be changed. So it should not stick on the walls of the tube. Also, it should not get vaporized. Because if the manometer is left for some hours, and if the liquid is going to get vaporized, then the amount of the liquid filled in the U tube will be becoming less and less. So the liquid should not get vaporized very easily, so that if it is left to the atmospheric pressure, or if it is left in contact with the air, its amount should not get reduced due to the vaporization. So these are the characteristics of the liquids which is to be used in the U tube manometer. First and foremost requirement is that its density should be very high. Okay, viscosity should be low, surface tension should be low, it should not get vaporized and should not get stick to the walls of the tube. Now here we have seen that the U tube manometer, it is used for the measurement of the differential pressure. It can be used for the measurement of atmospheric pressure and gauge pressures also, depending upon that how much pressure we have applied on both the sides. Suppose that, because here we have studied the differential pressure, so in differential pressure on both the tubes of the manometer we have applied the different pressure, that is P1 and P2. Okay. You can see in the diagram that here P1 pressure is applied and here P2 pressure is applied. So we are measuring the differential pressure. If we close this one side and only this pressure P1 is applied, so we will be able to measure the gauge pressure. Now here, if it is left to the atmosphere, okay, and here the pressure P1 is applied, so we will be able to find out the atmospheric pressure. Okay, so different pressure, atmospheric pressure, differential pressure and gauge pressure can be measured with the help of the U tube manometer by changing the arrangements of the tube. So here in this video we studied about the pressure measurement device manometers. We studied the U tube manometer here. We saw its construction, its principle of working. Then we derived the equation with the help of which we can find out the pressure difference or the differential pressure. Then we saw its advantages, disadvantages and the characteristics of the liquid which is used in the U tube manometer. So I hope that this topic is now clear to you. Thank you.